Hello, welcome to this Tech Talk that is all about SIEM event data de-identification, integrating the HPE Enterprise Security Solutions ArcSight and Security Voltage. My name is Angelo Brancato and let's get started. In this session, I'm going to do a basic proof of concept on how to integrate both HPE Enterprise Security Solutions in order to de-identify event data and depict the benefits from doing so. More precise, we are going to touch on the solutions HPE Enterprise Security ArcSight, Enterprise Security Manager, ESM, and HPE Enterprise Security Voltage Secure Data. But let's first quickly recap what those two solutions do in the first place. HPE ArcSight ESM is a very powerful security information and event management, or SIEM, solution that is market leading in collecting structured, machine-generated data and unstructured, human-generated data from the entire IT environment and do security analytics on it in order to find the needle in the haystack, anomalies and security incidents, to proactively act on that intelligence and achieve the highest of all goals, keeping up business continuity. In order to deliver that actionable intelligence in a real-time and automated fashion, HPE ArcSight is able to collect all necessary event data from the IT infrastructure and within the big data lake, normalizes and classifies the event data to the common event format, or CEF, and stores it in a correlation optimized database in order to do operational and security analytics on it. Whereas search and reporting, behavioral analytics, pattern discovery, and of course correlation are some of the key capabilities to deliver accurate and automated prioritization of security risks and compliance violations in a business-relevant context. Please go to hp.com/go/arcsight to learn more about our HPE Enterprise Security ArcSight portfolio. HPE Security Voltage, however, is HPE Enterprise's data-centric security solution, protecting data in its entire life cycle. And data de-identification is a key technology here. Data de-identification is the process of rendering sensitive data meaningless to attackers and at the same time useful to both production and non-production data processes, such as applications and services that need to process that data. Okay, let's put some more color around that. What we see here is a tax ID number that was encrypted with an AES algorithm. Now, does that qualify for data de-identification as described? Of course not, because while the data is meaningless to an attacker, it completely changed the format, and it cannot be processed as a text ID number by the corresponding application and do analytics on it without the need of decrypting it. HPE Security Voltage's Format Preserving Encryption, or FPE, encrypts the data while also preserving its format. And so it effectively retains the original intent of the data without exposing the real data. And the implication, of course, is that the data is protected in its entire life cycle. It doesn't need to be decrypted in order to be stored in the database. It doesn't need to be decrypted when using third-party services managing that data. Basically, it never gets decrypted in the database or backend, but only in the client application when an authorized user retrieves that data. Format preserving encryption can also be applied partially on the dataset to preserve certain information, like the area number in the first 4 digits of that social security number in this example. Secure Stateless Tokenization, or SST, is a second method for end-to-end data protection and very similar to the format preserving encryption, with the one difference: it is not encryption at all, but tokenization. So the protected dataset does not hold the original data. It is a token, a surrogate for the original data. One must not fear that if the encryption algorithm is broken, attackers could decrypt the data because, again, the original data is not in there. Like with format preserving encryption, we can do partial tokenization or obvious tokenization. A very positive implication when using this approach can be found in the payment card industry. Each and every system holding, processing, and sending tokenized credit card numbers fall out of the PCI data security scope because they do not process credit card numbers. But their tokenized versions, which means a huge potential in saving total cost of ownership. So, in general, HP Security Voltage is able to protect data end-to-end by using data de-identification. Processing de-identified data has also the advantage of potentially saving a lot of money. For example, because the backend systems do not need to be PCI compliant, but at the same time enable all kinds of new and effective business models like cloud, outsourcing, and big data analytics. Please go to hp.com/go/datasecurity to learn more about the HP Enterprise Data Security portfolio. Okay, now let's talk tech and see how we can use de-identification for security information and event management. Let's say we have Windows logon events with personal identifiable information or PII in it, like for example the username, that needs to be anonymized by some mandatory regulation policy, but at the same time the original event also needs to be accessible by a specific group of security analysts. In this POC we use secure stateless tokenization for de-identification, and the process is quite simple. The specific attribute in the syslog event message needs to be de-identified before the SIEM receives that event message, putting the HP Security Voltage Secure Data Service in between the event source and the SIEM solution. The HP ArcSight ESM database then stores and processes only the de-identified version of those events. At the same time, the mentioned authorized security analysts need to be able to identify or de-tokenize specific users in an on-demand fashion. The data de-identification needs to be implemented as early as possible and as close as possible to the system that generates the events. HP Security Voltage has many application programming interfaces to do so. In this POC, we will use a custom Python script that receives the syslog event over the network and calls the Voltage Secure Data CLI API to tokenize the corresponding attribute. Then the syslog message with the de-identified username attribute gets sent to the ArcSight Smart connector and eventually to the ESM database, ready to be correlated. In order to gain back the original username and de-tokenize it, all the authorized security analyst has to do is to right-click on the specific de-identified username and issue an integration command from within the ArcSight console to the Secure Data Web API to get back the original attribute. So in this short demo, we want to receive Windows logon event messages and de-identify the username attribute source user. Then within the ArcSight ESM console, pick any base event with a de-identified username in it, right-click on that username and invoke the integration command to de-tokenize the attribute. Let's open the HP ArcSight ESM console and wait for a Windows logon event with a tokenized username in it. There we go. We right-click on the source username and issue an integration command in order to de-tokenize that dataset. And we get back the original username. And that's basically it. But let's see what happened behind the curtain. Let's first take a look at the Python script that receives the original event message and invokes the Voltage Secure Data CLI API in order to tokenize the username. And the important part is on the syslog server routine that listens on syslog messages coming in. This if statement launches the Secure Data CLI client utility vProtectData if there is any attribute to be tokenized. Okay, let's now run the script and tell it that it needs to tokenize the attribute source user. And here is our first logon event where the source user Angelo Brancato got tokenized. So the script will replace the original username with its token and sends this message to the ArcSight ESM. And here we are back at the ESM console, accessing the original data with an integration command to the Secure Data Web API. In a productive environment, we would of course use TLS for securing that communication channel. Now let's go ahead and take a look at the integration command itself. And this one is pretty simple. It will just call a PHP script, passing the selected item, which is the tokenized username, in an HTTP post request to a custom PHP script. And all that PHP script does is using the same Secure Data CLI utility, but this time to detokenize the attribute and present the result in an HTTP page. In the next scenario, ArcSide's correlation engine detects a fraud in de-identified credit card payment events. The events must be de-identified because the Security Operations Center is an outsourced managed service security provider and/or not PCI DSS compliant. But as we know now, that is not an issue, because all they have to do is to detect the incident, create a case, and assign the case to the Computer Emergency Response Team, which has PCI compliant systems and is authorized to process the credit card information in clear text. Let's go back to our ArcSide ESM console, and as you can see on the red notification bubble, we already have a case in the onboard ticketing module. Because this correlation rule triggered and automatically created the notification. Now we can go ahead and view the base event that was responsible for that rule to trigger. We grab the tokenized credit card number and detokenize it. Voila! I hope you found this short Tech Talk session useful. Thanks for watching, talk to you soon, take care and ciao!